Hello, and welcome to the Field Guides. I'm Bill, and I'm here with Steve. Good afternoon, Steve.
Good afternoon, Bill.
What we're going to do today is give you the experience of what it's like to be in the woods, in the field, and on the trail. Each month, we pick a natural history topic, research the science behind that topic, and then take you out to a natural spot and share with you everything that we've learned. And today is a part 2.
Yeah.
We should say right now that, folks, if you have not listened to part 1, you probably want to go check out part 1 of our Dawn Chrous 2-part episode. And that's what we are here to talk about today. Before we turn on the mic, I'd mentioned to Steve that, if we were real men, what we would have done, real podcasters, we would have been out this morning at dawn to record this episode during the Dawn Chrous.
And it's not like we're not capable of it. I'm up at 4:30 in the morning feeding my baby. You're up at 4:30 in the morning setting up the mist nets for bird baby.
Nope. No. So I have been going out, though, at dawn. I mentioned last episode that sometimes what I like to do is go out in the morning when the dawn chorus is occurring, set up Merlin and listen to what birds are around while I'm at the same time recording what I'm hearing and kind of use Merlin as a check to see, am I hearing what's actually out there? So I've been doing that, a few days a week, and my record for the number of species heard in a 5-minute window just this past month was 21 species in one morning.
Nice.
So, and if I'd been out there for more than 5 minutes, it probably would have been more. So it just gives you a practical, real idea of how many species are involved, at least in my little corner of the world, during the Dawn Chorus.
Yeah.
I want to remind folks, if you listened to the part 1 a month ago, and it might be a little rusty on what we covered, I'm just going to do a quick overview of what we covered in that episode before I dive into the bulk of part 2.
I'm rusty on what we covered in part 1.
I was too. So remember, I'm basing most of this on a chapter from a text on animal communication, and the chapter was called the Dawn Chrous Revisited. They covered 9 hypotheses. I'm going to cover about 5 or 6 of them. We did 2 last time. The first one...
We're only doing the 5 or 6 worst hypotheses.
That's right.
Yeah.
These make no sense at all. But actually, the first one we covered last time was about how male birds might be manipulating female mating behavior around the breeding window. So when they're
typical
fertile.
Males.
And they might be doing this for 2 reasons. One, they want to increase female receptivity to copulations. Or 2, they might want to protect paternity at a time when other males could approach fertile females. And I feel like we need to get into this a little bit because last time, Steve, you alluded to the fact that birds are always out there looking for mates outside their pair. And we talked a little bit about it. And I did put it in the episode notes. And there's social monogamy and sexual monogamy. So when we talk about how birds mate for life, that might be a social bond.
Okay.
Or it might be a sexual bond.
Okay.
If it's a social bond, then we know that extra pair copulations are happening. The female might be mating with other male birds outside that bond. The male might be mating with other females that are bonded to other males. And in birds that are bonded sexually, we're not sure how often it's happening, but from what I could find, the general consensus is that monogamy is the exception when it comes to birds, whether they're socially monogamous or sexually monogamous. There's a lot of outside action going on in the bird world. It's just a common thing that birds do. So that first hypothesis was really around males trying to maybe manipulate the females into being more responsive, whether it's their own mate or a bird that's mated to somebody else.
Sorry, I'm just smiling because I'm just imagining like an Evo Psych bro, like being like, "Nah, babe, like this is evolution.
Natural."
Yeah. Trying to,
I know you're with somebody, but yeah. All right, so the other hypothesis we covered was around territorial defense and social dynamics. So we talked about how it's thought that it probably benefits birds to sing at dawn to kind of reinforce that border defense, since new males or males without a territory are going to be trying to find a territory that's open. And since nighttime is the longest time in a 24-hour cycle without the birds communicating to each other, you're going to kind of want to reestablish those territorial boundaries.
Right. No one's going to advocate for you. You know what I mean? Like, you got to be letting people know that this is your territory.
So, but we did point out that different species of birds during the Dawn Chorus will sing at different areas within their territory. Some sing at the edge of the territory, some sing at the nest, some sing in the middle of their territory. So different things are happening with different birds. And that's why I have to do, as I did in the last part, is we need to do a CYA. It's not likely that one of these hypotheses, or even a few, will explain something as complex and widespread as the Dawn Chrous.
CYA?
Cover your ass.
Oh,
You don't know that?
I guess not.
Steve learned something in this episode.
Yeah.
So it's likely that numerous factors are at play, including ones that no one has thought of yet. And there's probably different forces. I can say almost certainly there's different forces at play for different species. So we're just having fun exploring the big mess of evidence and ideas that are out there. I also want to point out, in the last part, we talked about William Thorpe. He was that British ornithologist that first started to bring the sound recorder where you could get a visual representation of bird sounds.
Right. That you'll still see in field guides and stuff.
Right.
Yeah.
And Merlin, the app that I was talking about at the top of the episode, that uses those visual representations to help identify birds. Now, you wondered if there was a law or some kind of... Yeah.
I was about to say that, where I'm like, I know Thorpe from somewhere, like Thorpe's Law or, I don't know, Thorpei.
You read the episode notes, right?
Yeah, I always do. Every single time. And sometimes when I'm supposed to do the episode notes, I do them too.
Well, I'm going to cover this just for the benefit of the audience.
Thank you, because I know it.
Yes.
Yeah.
So I could not find any Thorpe's Law or a rule associated with William Thorpe, but there is a Taylor's power law that has to do with some heavy math within ecology, and even the explanation of the rule, which I put into the episode notes, I didn't quite understand what it meant.
Okay.
So I did.
What was it related to?
It was, I can't even remember.
All we know is the name of it. Okay.
It was so over my
Taylor's
head.
Power law.
But I did put in the episode notes, if someone can explain it to me in words that I can understand, please do so.
Yeah.
I would appreciate that. So I did want to focus on that, though, because I mentioned that William Thorpe, the British ornithologist, he was the one that, through research, was able to definitively show that bird calls are innate and bird songs are learned. When birds are young, they learn their songs from the adults. But when I was editing and making the editing notes and doing some extra research, I found it wasn't that simple.
Well, I feel like cowbirds already make it not that simple.
I mean, there's always exceptions, right?
Yeah.
But
I say that because they're nest parasites, and they don't grow up with their own species raising them.
Right.
Yeah.
You seem very subdued today.
I have a 1-month-old. Actually, she's good, though. We're getting a good amount of sleep, and we take turns overnight, so
right.
I'm just tired. I also cut my grass on lunch today, so that might have sucked out a lot of my energy. So.
And you not only have a 1-month-old, don't forget about your other child.
Who?
Who is relatively small.
Yeah, 2 years old. Yeah.
Okay. So I want to talk about how passerines, these perching birds that we talked about in other episodes before.
Songbirds, a lot of people call
this general
them
group, right? They're actually divided into two groups. I hope I'm saying it right. Oscines and suboscines.
Oh, I didn't know this.
You didn't know? I didn't know this either.
I feel like I'm a taxonomy guy, so I feel like I would have heard of this, but I
so,
guess
have you heard of the syrinx in birds?
Yeah, it's their the way they vocalize, right?
Yeah, their specialized vocal organ. And shout out to Rush 2112, the Temple of Syrinx. Do you know about that? All right. Well, I'm sure some listeners out there right now are making what do you call that?
Devil's horns.
Devil's horns. Yeah.
By the way, I also wonder if I'm a little bit subdued today because it sounds like both of us are talking in the most echoey stadium ever right now.
Because of your new headphones?
Yeah, because we're using different headphones this time.
Steve hasn't figured out the new headphones yet.
Yeah, and it's a little distracting. It's fine, but
all right. So most birds, or I should say, most passerines, belong to the oscines, and they have a highly developed syrinx. So these birds are born with innate calls, but then they learn their song from the adult. And that is a general rule.
Yeah.
There's probably some exceptions. But birds like eastern wood pewees and flycatchers, they are suboscines, and they have a more primitive syrinx. They're characterized by innate rather than learned vocalizations. Okay, so this includes all the flycatchers.
They don't have a very complicated song or anything,
no,
right?
they're the one that I actually played the song in part 1 of this episode. Remember where it was slightly different? So there is some research that suggests that if an individual bird is exposed to adult songs or calls at an earlier age, their call or song may be modified slightly. But generally speaking, if they're raised without hearing adult songs, they'll still produce their species-specific songs. So when I said that birds' songs are learned and their calls are innate, that was a gross oversimplification.
Sure. But there might be dialects that are learned.
You're taking it even a step further, all right? Now, let's get into the other hypotheses. So we gave you the background, folks, with those first two. Now we're going to get into hypothesis 3, and this deals with early singing as a handicap. So when we're talking about wildlife and a handicap, we're talking about the handicap principle, and this is certain traits signal an individual's ability to squander a resource. And what does that indicate, sexually speaking?
That they're lousy with that resource.
In a good way.
Yeah,
right? Yeah, they're a high quality mate.
Right.
So think of a peacock, right?
Yeah, that saying is so funny, though. Like, I'm lousy with,
right.
It just means you have a lot of it. And
I've used that before on social media or in family texts, and I've had people say, what are you talking about?
Yeah, right.
They're
is
like,
it not a common thing?
Apparently not.
I guess not.
It's not as common as CYA, right?
I'm lousy with energy right now. I can sing all I want.
All right, so this handicap principle, think of the peacock. Individuals of inferior quality, they can't afford these extravagantly wasteful signals. And these costly ornaments, when you think of a peacock, you think of feathers, but it could also have to do with song or behavior.
Right.
If you can afford to do something that's costly, you're kind of showing potential mates that you're a high-quality individual. And the cost usually goes up the more you express these signals, right?
Right. Like the peacock evolved probably through sexual selection, all of these very showy things. But if you have like a good feather quality versus a poor feather quality, the good feather quality probably means you're eating well, you have good whatever, you know, like you're in good breeding condition.
Yeah, good fitness.
Yeah.
Now, several studies have found that how birds engage in the dawn chorus might offer signals about a bird's fitness. In other words, if a bird sings earlier or longer compared to their neighbors of the same species, that bird might be showing the world that they got it going on.
Right,
They're high quality. Now, it's funny because in the chapter, they said that the suggestion that early singing in the dawn chorus, the fact that it might act as a handicap, was proposed in 1985. And this assumed that singing at dawn is costlier than at other times of the day. And then they said, it is by no means clear why this is so. So
just say, I think it's costly.
So I tried to find the paper that this referred to, the 1985 paper, and it was a presentation that a researcher made at a conference in 1985. And it was published, obviously, in the proceedings of that conference.
Right.
But I could find no way to look at it.
Yeah.
So I can't find the actual words that this researcher used.
Yeah.
But I should say that the authors of this chapter, they did go on to say, several lines of evidence do suggest that early singing, at least in some species, does fulfill some of the requirements of handicapped signals, of signaling, hey, I'm a high-quality individual. There's kind of three main ones that it has to meet. It's got to be energetically costly or risky.
Right.
So in terms of the dawn chorus, before things warm up, it might be costlier to expend all that energy. Also, you're singing while predators might be active. There could be owls out, right? It's linked to condition or quality, and it should be repeatable. It should be something that the individual is going to be doing over the course of the breeding season or whenever they need to.
So these birds are being bold and boastful and reckless.
Yes.
And let's just say they're bad boys, all right?
Like Steve.
Yeah. And, women like bad boys, as we all know.
So studies have uncovered, at least in some species, that early singing birds, I should say earlier singing birds, do tend to be larger, older, or the dominant individual of their species in the neighborhood.
Wow.
All right, so that kind of matches up. Some experiments have found that birds that are food supplemented, what does that mean?
They put out feed for them.
Right.
Yeah.
That they tend to sing earlier as well. Early singing willow tits, a species of Eurasian bird, responded more forcefully to predators.
No way. Are we talking about tits again? This is a totally different study, and we're going right back into...
We are. Linda was very disappointed that we didn't jump on that and make some kind of joke. And I said, it's the low-hanging fruit.
Yeah.
It's just too obvious, right?
I made a couple jokes.
They were pretty subtle.
Well, I said, all right, I don't need to... If you have to explain the joke,
That's right.
It wasn't
Go back and
joke.
listen to part 1.
Yeah.
So those birds responded more forcefully to predators, and they were more likely to survive the season than late singers.
Survive the season?
Yeah, make it through the season.
Turns out it wasn't more risky to sing early.
No, because they're tougher.
Oh,
okay.
I
They were
see.
better at surviving.
They're a better physical specimen.
Exactly.
Yeah.
But as this paper is very good at doing, they kind of present the case, but then they also present counter information, which I really appreciate. And that's going to come up again and again. And it may seem frustrating, but I kind of admire it because they're trying to look at this issue from all sides. You know, why are birds singing together at this particular time of day?
And I think this is sort of related to, I can't remember who said it, but we're trying to model this birding behavior. And there's a saying out there that like all models are wrong, but some models are useful, right? So like it helps us understand a behavior in some way. It's like maybe a little bit too simplistic to represent real life, but
it gives us some idea of what's
some predictive power using the model.
Well, they did say one study found in great tits that earlier singing birds were younger ones, although the tendency was non-significant. So they kind of went out of their way to point that. So, but again, I appreciate that they're kind of saying, well, this little bit of evidence is out there. So non-significant. I'm sure some of our listeners might want to know. Explain that.
So if the mean age of the birds was lower, but it wasn't significantly lower. So there's always a little bit of error around a mean. And if that error is overlapping with another mean's error too much, then they're not really different from each other because there's always a little bit of error in each measurement we take.
That's much clearer.
Was that?
Just kidding. I'm kidding.
I'm trying.
I appreciate it.
Yeah.
All right, so if you want more proof that early singing is a fitness advantage, let's look at our old friend, extra pair paternity, which we already mentioned in this episode. I mentioned it last time. These birds trying to find a mate outside their bonded pair. So this hypothesis, the one about handicap, wraps the second part that I mentioned.
Why did I use the word mean instead of average? Like, I don't know what I was
thinking. You're
showing off. No, I wasn't showing off. I just wasn't thinking about that I'm presenting an idea.
Steve is going to focus on this for the rest of the episode.
Yeah.
I'm sorry.
I really blew it.
No, I was just kidding, right?
I just jump into the river right now. Actually, that's just a little
I'm not
creek.
Kidding. All right, so the second part of that hypothesis that I mentioned at the top of the episode talked about how males may be trying to attract a female outside of their bond. So this hypothesis wraps that into a larger idea around a male advertising his fitness. Several studies have linked earlier singing with higher success at getting those extra pair offspring. Remember in part 1, we talked about how male great tits were given melatonin, and those guys woke later in one study, and they lost more paternity than the control birds.
Right.
So repeating these results, eastern kingbirds that sang earlier had higher numbers of extra pair chicks outside their pair. And cuckolders sang earlier than cuckoldees. So if you were out there getting the business done,
you're a cuckoldee.
No.
You're causing someone else to be a cuckold.
Correct.
Right?
Yeah. Now, a little aside here. I wondered if cuckolding is only a male thing. Turns out it is.
Really?
A female would be a cucquean.
No way.
Cuckquean.
Wow.
In evolutionary biology, that refers to a female that's investing parental effort in offspring that aren't her own. It's not clear whether the advantages gained by these early singing birds was a consequence of males using the period before dawn for pursuing extra pair mating, or if females chose the early singing birds. All right, so I'm going to say that again. So if you have these males that they're singing earlier kind of than most of the birds are, is it because they were just using that time to pursue mates outside their pair? Or is females are listening, they hear a bird singing earlier, and like, I'm going to go after that. Or is it both happening?
Right.
A clever study tested this with Lincoln sparrows. They played male songs to females at different temperatures. So the same song at different temperatures.
What do you mean?
So they would play the same song, but they would play it at colder temperatures or warmer temperatures. Let me finish. The ladies preferred songs that they heard at very cold temperatures.
Oh, because it's colder when it's earlier?
Yes.
Oh.
Yeah, temperatures are typically colder.
I was wondering if there was some type of vocalization that was analogous to cold or warm.
No.
Like if it was a bassiness versus a,
You sing higher when it's cold, right?
Like, you're not speaking a language I'm understanding, Bill.
That's why I'm explaining it slowly.
Here, let me sing coldly.
So at least in Lincoln sparrows, it might be more about females choosing the early birds.
Ah.
Now,
I'm glad we're hearing about sparrows, though, because we've been hearing about flycatchers.
Right.
Even the kingbird, or...
the kingbirds and the wood peewees.
Yeah.
So to recap, there's several lines of evidence suggesting that early singing, at least in some species, and I should say earlier singing.
You every single time.
I know. I even have it in my notes.
Yeah.
It fulfills some of the requirements for handicaps. But despite these suggestive findings, we don't have a clear picture of the costs that are paid. In a true test of this hypothesis, it would need experimental modifications of singing time. And they're difficult to induce. Even if we're tampering with melatonin levels, like in that one study, these authors, they said, you know what, there's a lot of effects related to that hormone that make results difficult to interpret. So this is still an area of active research. Like, is it a handicap? Now, folks, I want you to remember this handicap hypothesis, like our birds showing off their fitness, the ones that sing earlier, because this is going to come in at the very end of the episode. So now we're going to move on to hypothesis 4, and this has to do with foraging. Oh, I just realized hypothesis 4 is about foraging. Now, dawn doesn't appear to be a good time for birds to forage. I mean, think about it. There's two big issues, low temperatures and dim light levels. It's been shown that arthropod activity, insects and other critters, is greatly reduced at low temperatures, making it harder for birds to find them.
Well, because they're just burning calories just to stay warmer at that time, right?
Well, they're...
Well, I know in the winter, birds are burning a lot to stay warm.
Oh,
right?
Yeah. Yeah. I mean, remember, arthropods are cold-blooded, so it's a different kind of mechanism at play there. So they're going to be moving slower. They're not going to be as active and moving around. And obviously, low light levels limit a bird's ability to search. So that's going to make anything foraging they do at the time is going to be less profitable. And that's not just for insect eaters. That's going to be for seed eaters as well, because you're not going to see as much. So maybe this is why birds concentrate so much singing at dawn. Maybe because it's spare time.
Right.
That's what this hypothesis suggests.
Like,
because,
hey, I'm waiting around till I can see anyway,
right.
so why not...
why not sing? Why not try to get some? So if that isn't true, aren't birds trading precious feeding time to sing? If it's not true that foraging is less effective at dawn, right? We're kind of giving you reasons why it's so.
If it's true that it's not easy to forage.
And again, if this hypothesis is true, it means birds need less sleep time than the whole night. And there are several lines of evidence that suggest this is the case. There's studies that analyze differences in bird activity across latitudes, and they show that birds are really remarkably flexible in their sleep requirements, and that a big constraint on their activity is low light levels. Secondly, it's been shown that late singing species spend more time awake just waiting to sing than early singing species. The evidence is largely anecdotal, but it does support the idea that the length of the nighttime in spring exceeds what birds need for sleep time. Also, people that have studied migratory restlessness, so this is the idea that around time of migration in spring and fall, birds get restless. I've seen these cool studies where they'll take birds around migrating time and they'll put ink on their breasts and they drop them into a cone, and the ink will record movements against the cone. And I know Steve's making a face. In the fall,
if you dropped me into a cone,
but you don't migrate. But when you look at the imprints of the ink in the fall, it's mostly to the south, and in the spring, it's mostly to the north. Like, it's so cool.
That's super weird.
And during migration time, there's way more because they're more restless. They need to move. Their instinct is telling them to move. So studies on this migratory restlessness, it shows prolonged overnight activity or around-the-clock singing. And in birds like nightingales and pectoral sandpipers, they'll be engaging in mating patterns round the clock. So they're not getting regular sleep. So if birds don't need sleep for the whole night during the breeding period, it makes sense that dawn is used for singing, an activity that doesn't require acute vision. This hypothesis has received some additional support from game theory model. Shout out to our downy woodpecker, hairy woodpecker.
Oh, yeah.
Episode where we talked a lot about game theory.
And the movie A Beautiful Mind. That's a really good one with Russell Crowe.
Yes.
Right, Russell Crowe?
Russell Crowe.
Yeah.
When we say game theory model, folks, we're talking about this isn't based on actual out-in-the-field studies. It's based on mathematics.
Yeah.
But this predicts...
And it's so weird because it's like a type of mathematics that you don't think is mathematics when you first are introduced to it.
Yes.
So
I still don't think of it as mathematics.
It's confusing.
And this predicts, like these models predict the occurrence of both a dawn chorus and a lower level dusk chorus by simply allowing feeding profitability to vary. So if they say, in this model, they say, well, profitability, am I saying that right? Profitability.
I thought you were trying to say probability.
Oh no. What was the word from the last episode? Cacophonic. Cacophonic. That was it.
Cacophonic. There's no way it's cacophonic.
You don't think so?
I don't
Cacophonic.
know. Okay, because I don't remember
Maybe that's
having
it.
the word.
That was for part one. So anyway, the word I was trying to say was profitability.
Yeah.
So by simply in the model, by simply allowing the profitability of feeding to vary, as it probably does in the outside world, it does show that there should be a dawn chorus and then a dusk chorus a little later on.
You know, I was going to ask about that, but I was wrestling with whether or not I should bring it up, because just think back to bird banding, right? Like, it's super crazy when we first start.
Oh, yeah.
And when I say we first start, I haven't done it in a little while, but when we first start, the birds are going crazy, but then we usually are done by like noon or 1-ish or whatever. Yeah. And there's like a lull at that point. Like, it's much less singing, it's much quieter.
Much less singing, much less activity. We don't catch nearly as many birds around that time, usually.
But then I think later in the day you start hearing more singing.
As you move closer to dusk.
Yeah,
definitely. Well, let me wrap up this part.
Sure, yeah.
Because I'm hearing a bird right now that I want to talk about.
Okay.
So just quickly to wrap up this section on hypothesis 4 of our own foraging, the study of comparative sleep in birds is really in its infancy compared to mammals. Evidence so far does show that bird sleep has what they called in this chapter important peculiarities. So right now, people are developing small sleep data loggers, which are really logging how much a bird moves, how much light it's getting, and they're inferring their sleep patterns through that.
Right.
But this should allow researchers in the next decade to provide some important insights around this topic. So, we're talking about birdsong. We're hearing a lot of birdsong right now.
Yeah.
I'm hearing a redstart, which is a small warbler. We're hearing
Thrush.
a common yellowthroat saying,
Oh.
witchety, witchety,
Okay.
witchety. But that song, that really emphatic song, is a redstart. I'll put one in so people can hear it. We're here around
So two warblers.
4:30, 5 o'clock.
Right? Wait, redstart, warbler.
American redstart is a warbler.
Yeah.
Common yellowthroat is a warbler. And that's what, the mic is just picking up. We're hearing, I don't know, right now I'm hearing at least 6 or 7 species. But, we're still a good 4 hours away from dusk. We never mentioned where we're at. We're at a place called Majors Park. This is in East Aurora. We're about 15 miles from Buffalo. This park is 160 acres. I didn't realize that. And it's neat because it's cut almost right down the middle by Cazenovia Creek, which is a creek that flows northwest to Buffalo. It hits the Buffalo River just before it enters into Lake Erie. But we have a lot of second growth forest here, but there's quite a bit of wetland here too. So I'm wondering if we're going to be hearing a greater diversity of species because of that. I picked this because I figured the birdsong would be going right now, not as intensely as it would be during the dawn chorus, but I figured we'd pick up a lot of birdsong.
Yeah.
All right, so one last bit about hypothesis 4. An alternative view would say that singing earlier may use precious sleeping time. Like if it's not true that birds have this extra time.
So this is more of the handicap theory.
Very good.
Yeah.
And the alternative view would say the time of dawn song is a sexually selected character, like Llusia just said. And this would suggest that early birds may be sexually selected. But it's not clear, again, what kind of costs are paid. It's possible that an increase in predation, rather than the cost of reduced sleep, is the true currency of this mechanism. And that was a quote from the chapter. And that's what we're going to talk about now with hypothesis 5, predation.
Well, we're flying through these hypotheses.
So there's debate about predation levels at dawn. We mentioned that, maybe at dawn they're exposing themselves to more predation because owls might be around or these nighttime predators. But that is definitely not a universal assumption.
Yeah.
We can say, however, that predation is a key factor and it permeates pretty much every single aspect of bird behavior. But its role in shaping the dawn chorus hasn't been studied very much. It's not clear whether predation is higher at dawn or not. Some researchers, they've predicted higher than average predation risk, but others have proposed the opposite, with some saying that the dawn chorus happens when it does, at least in part, because of a lower risk of predation. That's why all the birds are doing it at this time. So you do have low light levels at dawn, and foraging could be risky if predator sight is better than the prey's. The authors couldn't find any experiment that has directly tested the influence of predation risk on singing at dawn.
Yeah.
It's not clear. A couple of studies on dusk singing have showed a perceived predation risk that it had an influence. So they did a playback experiment with male veeries, one of my favorite thrushes. They're the ones that go veer, 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 veer. And that showed reduced levels of dusk song in places where owl calls had been previously played. And then there were similar results from a study in Europe with tawny owls, where tawny owls called less at dusk in areas where there were high calling rates of eagle owls, a much larger owl.
Yeah, you would imagine with a name like that.
Right? So despite these results, again, the authors say, no study that we know of has analyzed whether indeed dawn is less risky than other times of day.
And now we've switched to talking about thrushes.
See, well, you were waiting for a different kind of bird, right?
Yeah.
But it's not a real thrush.
Oh, what?
No, wait, I'm sorry. I was getting confused by robins.
Okay.
So there's lots of questions here. If there's lower predation during the dawn chorus, is it because of dilution effect? Right? Because since many birds are singing simultaneously, wouldn't that reduce the chances of being located and predated?
Oh, yeah,
right?
I guess. Like the safer in a crowd type thing.
Right.
Yeah.
But again, I love how they ask these questions. They make this one comment and you're like, oh yeah, maybe. And then they're like, but what about this? Because then they say, however, that dilution effect would not explain why dawn is the best time to sing. It would simply select birds to sing together.
Right. Yeah.
So again, folks, I hope you're enjoying the ride and not just being continually frustrated by these like, well, what about this? No, wait, what about this? So it's important to know here, folks, that I'm only covering a small part of what was covered in this chapter. Again, they covered 9 hypotheses, but then again, a ton of other info around the dawn chorus. So believe it or not, at this point, I'm done sharing the main hypotheses. I've shared 6 in the last part, and including this part. But I want to share here some of the supplementary info.
Cool.
So the whole section about light, like what is the role of light in singing time, right? Since people have started studying the dawn chorus, they've found that higher light levels lead to earlier choruses, and that on cloudy mornings, birds usually sang later than usual. And this was super interesting. Species with relatively large eyes for their size, they start to sing earlier as well. The full moon can even have an effect on dawn chorus timing. So obviously the full moon, it affects lots of different things.
It's romantic.
Like, romance, behaviors.
Right.
Exactly. I had a woman recently suggest that my dog was having seizures because it was a full moon.
Oh, I'm sorry. I didn't know that was happening.
So, folks, we're joking. But I loved how the authors pointed out the actual increase in light and not the lunar cycle was responsible for the changes in behavior. So it was controlled for in the studies they're referring to. And even artificial light can have an effect. There was a major study that investigated the effects of night light pollution, and they found that 4 out of 5 species showed an advance in their singing in suburban areas with artificial lights. So they were singing earlier if there was more ambient light.
Makes sense.
And now I want to talk about anthropogenic noise, human-caused noise. And this is going to focus a lot on urban environments, because think about it. Noise in urban environments is lower late in the night and around dawn, so it makes some sense for birds that are living there to try to reduce the overlap with urban noise by singing earlier than they would in a more natural environment. This should lead to an earlier dawn chorus, right?
Imagine being a goose and hearing just cars going off constantly.
So
I know they're not passerines, right? But
that's okay. Now, since city birds, they'd want this window of communication at a time when noise levels were lower. The first study to detect this pattern wasn't able to separate out the contribution of light from noise pollution to the advance, to singing earlier. And I love that they were thinking about this, because they're like, oh, there's an advance. It must be because of the noise pollution.
Right.
But then people are like, well, wait a minute, what about the light? Because obviously there's going to be more of that in the city as well. But subsequent research has controlled for that, and they've shown that earlier dawn choruses in cities are due to increased noise levels, at least in some species. In studies around this, they would need to demonstrate that earlier singing, now stay with me here, think about this.
I'm trying, yeah.
They would need to demonstrate that this earlier singing wasn't caused by this extra noise waking the birds up, but rather the birds were anticipating the noise disturbance and sang earlier because of it. So think about it.
Oh.
If there's more noise in the city, it's just because the birds are like, they got woken up and they're like, oh, I'm awake, I might as well start singing.
Right.
But were they waking up earlier because...
It's like, those people are going to start making a lot of noise around 5:30.
I got to get this done.
Yeah.
So true anticipation has been documented in studies that examined song timing near airports, in which birds were found to sing earlier than in control areas. So they were anticipating the noisy start of airport operations.
There was a time in my life where I would set alarms and I would always wake up about 5 minutes before my alarm. I think I'm a bird. I anticipated that
You're
alarm.
part bird. You're part of an extra pair mating.
Yeah, and that's why I was setting my alarm.
One thing that was interesting was that in one of these studies, they found that the advance, the movement of when they started singing, was greater for late birds than for early birds. So I want to say that again. The birds that normally sing a little bit later in the dawn chorus, they moved their timing more than the early birds. This makes adaptive sense because there's more overlap with aircraft noise for the late birds.
Yeah.
And along those same lines, a study with blackbirds found that the advance was only detectable when the airport timing overlapped with the dawn chorus. Now, what about biotic noise? Noise caused by other wildlife. Thanks, Steve. Talk about low-hanging fruit, right? So I mentioned in the first part how in tropical environments you can have other, and really in other environments, not just tropical, you can have other wildlife singing as part of the dawn chorus. But especially in tropical environments, insects are a major source of noise for singing birds. So 2 different studies have examined whether birds avoid singing at the same time as cicadas. The first did show short-term avoidance. Birds reduced or stopped their singing when cicadas were calling. And the other study found similar avoidance of insect noise, and they showed that birds whose songs overlap even with the frequency of cicadas delayed their timing to avoid masking. Now, one thing I loved about this paper is they said, well, hang on, because this...
Hang on, maybe it's just a turnoff for the birds.
No, this second study, they said, well, this second study may suffer from a basic methodological problem because they collected data, so they were looking at these birds and said, are they stopping singing when cicadas are calling? They said their data collection was based on acoustic and not visual observation. And singing birds could have lower detectability because of higher sound masking.
Yeah.
So they were just kind of using a recording device to pick up birds versus cicadas. But these guys are saying, well hang on, because the cicadas might be masking the birds that are singing and you're just not picking it up. So I just love that they're saying, hold on a minute.
And then there's a third option where they're feeding on them. They're like,
the birds are feeding on the cicadas.
We're actually going to feed at this point. The cicadas are so loud, we know exactly where they are. Yeah.
So overall, the evidence suggests...
I actually have to imagine that maybe it's hard to pinpoint a cicada when there's so many going off.
Well...
they're all over the place. You just see them.
Folks, listen to our cicada episode. Remember how hard it was? It was just a wall of sound.
Yeah.
And we were there during the end of it.
But it was easy to find them. You and I were eating the cicadas left and right. So.
I actually wasn't eating.
I like how you say you weren't.
Overall, the evidence suggests that when you have birds and other critters in the same chorus, competition between them may cause some species to alter their singing time. So there were some other hypotheses that I didn't cover. This paper, as I mentioned, covered 9 different hypotheses, but I did want to talk about one that didn't have a lot of support, but I still found it interesting.
Okay.
And when I started looking into the dawn chorus and just reading kind of general articles for the general public about the dawn chorus, this hypothesis came up a lot, surprisingly a lot.
I know what this is going to be.
What?
That they're government drones.
Well, everybody knows that.
Okay, all right. So that's accepted regardless of the hypothesis.
Well, we're part of the conspiracy.
Oh, right.
We'll be getting our checks soon.
even joking about it is making people believe it less.
Yes.
Yeah.
So this hypothesis was around weather.
Oh.
And whether or not there's better sound transmission conditions at dawn.
Oh.
All right? Because think about it. Dawn is typically a pretty calm time of day. And weather is a factor impacting bird ecology and behavior. So most studies have found that bad weather in general, things like rain, clouds, storms, or low temperatures, tend to delay the onset of the dawn chorus. But not every species responds the same. So this hypothesis that I kept seeing proposes that dawn is the best time for sound transmission. Several studies have shown that atmospheric conditions before sunrise, usually when temps are low and air is calm, they do allow for better sound transmission than conditions later in the day, so this could lead to a longer transmission distance. But not all studies have been successful at finding better transmission efficiency at dawn. And this suggests that it's by no means a general advantage. So people have tried to refine this hypothesis, and they've said, well, dawn doesn't offer a better time. It's just a more consistent sound transmission time than others.
You know what? Can you think back to your young days where, because I do think about this from time to time, how the world's a totally different place when you're walking the streets with your friends, going to parks and stuff at like 3 a.m. You know, like, because the whole world's dead. But like the noises you hear from like just everywhere
At 3 a.m?
Yeah, you don't hear in the middle of the day.
True.
Because there's so much other noise that like you just can't focus on these things that you didn't know that there was this thing that made so much buzzing, or you know, or like the power lines, you can't hear them, or you can, or you know, it's kind of amazing how different
Sound
the middle of
can be
the early morning is versus middle of the day.
Oh, definitely.
So, yeah.
So this hypothesis, it has an important limitation. Even if we accept that atmospheric conditions are on average best at dawn or more consistent at dawn, the high number of birds singing at that time should impose what we can call huge perception costs that would most likely reduce the advantage. Because, well, hey, if it's better at this time and everybody's doing it, it's going to be hard to hear. So the dawn chorus can be so noisy that it's been suggested that switching singing to a dusk chorus would be a good strategy to reduce overlapping of song at dawn.
But I wonder if the answer to that is the fact that so many of these birds have such different calls and songs that when you're standing in a field, even though it's like overwhelming all the different songs that are coming in, if you try, you can focus on one particular song.
Well, I have two answers to that.
Okay.
Because, right, maybe one particular species of bird is better at filtering out other species.
Mm-hmm.
But remember, you're going to have multiple individuals of the same species singing at the same time during the dawn chorus. And secondly,
but you have territories and stuff too.
You do. But the authors said, and I quote, "In general, we believe that sound transmission does not offer a good explanation for the maintenance of the dawn chorus." Boom.
Yeah, so their part of their point is because they could do it at other times when there'd be better transmission, but they're not. There's something special about the dawn. So
if you hear someone pontificating about the dawn chorus and that's because of sound transmission, it's better at dawn, you can push up your glasses and say, actually. So let's get into our conclusions. The authors of this chapter, they said a lot of work has gone into studying the dawn chorus in the past 2 decades, but obviously there's still a good degree of confusion. Much more work is still needed. 4 out of the 9 hypotheses they covered to explain it haven't been empirically tested. Now, if you out there listening, if you really want to find out more about the dawn chorus, I'm going to post a link to the article because they have a handy dandy table in the article, and I should say chapter, because again, it's a chapter in a text, where they list the key findings for each hypothesis and their evaluation of the evidence supporting them, and then specific suggestions for more research. So in spite of this plethora of explanations, most hypotheses, they went out of their way to say this, are not incompatible with each other. Now, remember I said to hang on to that handicap proposed, the handicap hypothesis? So there's an interesting distinction among all of these hypotheses. Optimality versus costliness. And what I mean by that is most of these hypotheses assume that early singing is a smart, low-cost strategy that helps every male equally. It's optimal. But in contrast, that handicap hypothesis kind of goes off in a new way. It proposes a cost-based view, that the behavior isn't efficient for everyone. It's costly, and it just benefits the best males by advertising their quality to mates or rivals. But the authors say these two views, they're not incompatible.
Well, I was about to say, like, there can be the most efficient time, but they're putting out like an amount of effort that could be a handicap.
Because remember, I kept correcting myself?
Yeah.
And instead of just
earlier.
Right. Yeah.
And in fact, it's written in your notes. Earlier.
Not early, just earlier. Because in the case of birdsong, we expect that whatever general advantage is accrued by singing early, there's going to be variation between individuals, and a lot of that variation is going to be based on physical condition. So, in other words, while some hypotheses explain early singing, the handicap hypothesis aims to explain earlier than average singing. So, I'll say it once again. I hope that this kind of back and forth and this refinement, this continual refinement isn't too frustrating for the listeners. I find it fascinating to kind of listen to all these ideas, how they overlap, how they compete with each other, but then how they can kind of link up with each other.
And to be honest, a lot of these phenomena that we look at,
Yeah.
a lot of times I'm not really thinking about them. I just sort of accept them. I'm like, birds sing in the morning.
Right.
So I think just knowing and hearing about all these hypotheses and how people are testing them, just that I find super interesting, even if we don't have like a perfect answer. But it seems like there's a lot of promising ideas here.
Oh, definitely.
And intertwined with each other. And
this is a huge open area of research. And I also think for most of the people that we know who don't even really think much about the Dawn Chrous, I know one woman that I work with.
You could have stopped with think much.
One woman that I work with who appreciates nature. She last spring was talking about coming in saying, "Oh, isn't it wonderful how the birds are singing? I wonder what they're singing about." And I was just like, "They're singing about sex." She's like, "What are you talking about?"
Yeah.
And I showed her. I'm sure folks out there, you've seen it. There's lots of cartoons out there that said, what are birds singing about? It's all like, do me,
right.
Sit on my face.
Oh my God. when so there's this wonderful class at UB for, I think it's just bio majors, but maybe they offer like it to non-majors, but it's Bio 200, it's evolutionary biology. I think on the first day of class, the professor Jess Poulin, there's a couple other professors, but she's who I had. I think that she immediately starts with biology or evolution is all about sex. And it's like big on the PowerPoint slides and everything.
Now that I have your attention.
Yeah, and obviously it's a justified claim.
Right.
But it's sort of a shocking way. We don't live in a society where we're necessarily always talking. Well, actually, maybe some people would argue we are always talking about sex, but
at least in your house, Steve.
I don't know. Maybe in our households we weren't always talking about sex growing up, so for me anyway, it was shocking enough to have this memory to recount.
Right.
So,
but it's so true. It is all about sex. Now, the authors make a point of saying here, one interesting possibility is that a big selective pressure for dawn singing is synchronicity in signaling. So singing together. This would not explain why it pays to sing at dawn, but rather that there is strong selection for singing together. This type of synchronous signaling results in a dilution of predation risk, which we talked about before, and a decrease in invasion rate. Because if you're one bird trying to listen for an open territory and lots of birds are singing, it's going to be hard to know what's open. And this allows signalers to kind of compare each other, as well as favoring the development of useful communication networks. We believe that this possibility has not been sufficiently explored. So saying, this area of why are they all singing together at the same time? I know it seems like we've kind of been talking about that the whole time, but they really feel it needs to be looked at more specifically. And then get this. At the very end, they said, an important omission in our review is female song. A series of studies have emphasized that female song is more widespread than traditionally assumed, actually being the ancestral state in birds.
Oh.
What that means is it evolved before the male-only singing pattern seen in most modern birds. Now, in many of our temperate species, males sing more than females, but in tropical regions, females sing just as much or even more in some species.
That's interesting.
And then I'm going to quote them. However, research on female song is still underrepresented in the literature, and we found almost no reference to female song in the Dawn Chrous literature. So they believe very interesting insights will be gained by comparing male and female patterns of singing with respect to dawn in those species that show female song. So it's going to get even more complicated.
Yeah, I know. We really, technically, we were dealing with a subset of the Dawn Chrous.
Yeah, you know how people say, like, most medical research, we say, a lot of it's based on mice, but it's really based on male mice.
Right.
Not on female mice. I mean, it does make a difference.
Right. It's like you're talking about mammals, but we're only focusing on the hibernating ones or something.
Right. There's one subset.
Right. And those that's like the minority.
So it kind of blew me away when I read it. I'm like, oh my God, like almost everything we've been talking about, it's all these studies, they're just focusing on males singing.
Yeah.
So I want to end with a quote from a man named Ernst Mayr. Have you heard of him?
The name sounds vaguely familiar, but I'm sure there's plenty of Mayers out there. You said Ernst?
Ernst, this is why we're pathetic.
Yeah.
Because if you ask ChatGPT who is the greatest biologist, of the 20th century.
It would say Ernst Mayr.
Well, depending how often you do it.
Right.
But Ernst Mayr is known as one of the greatest biologists of the 20th century. Why haven't I heard of him? So
soon it's going to say me.
So over the course of the 20th century, he made major contributions to the biological idea of what is a species.
Oh.
He was a taxonomist. He was an evolutionary biologist. He was an ornithologist. He had a lot to say about Richard Dawkins and why Richard Dawkins is wrong and placed way too much focus on genes.
Really?
I've been listening to some different information about Stephen Jay Gould and his contributions, and when I looked into it, they're like, Ernst Mayr had way more broad impact than Stephen Jay Gould on biology.
Really?
So look into Ernst Mayr, folks.
I'll admit that I never took a course where we really dug into the species concept.
Yeah.
Yeah, so it was all just my own reading that I focused on.
Yeah, me too.
So, but I know that universities offer them because even at my own university that I work at, there's courses that they focus on that question.
Yeah,
so,
it's a huge question.
Yeah.
So that's Ernst Mayr, M-A-Y-R. And he concluded,
I didn't expect that.
He concluded that most, if not all, biological processes are probabilistic, which means they're the result of several factors with a high degree of randomness. So this naturally leads to multiple hypotheses being correct at the same time. The authors of this paper, they believe that research on the bird Dawn Chrous represents a good example of this. And it really illustrates how several hypotheses can coexist simultaneously. And I just felt like I had to say that at the end because out of everything we covered in these two parts, all of this might be true, or things that we haven't talked about, people haven't thought of, that might be true. Except the fact that sound transmission is better at dawn. We know that one's garbage. Right?
Yeah.
All right, so that is everything I have on the Dawn Chrous. We are now experts on the Dawn Chrous as well as our listeners.
And I feel like I have to do more reading up on Ernst Mayr.
Ernst Mayr, you and me both.
Yeah.
All right.
I wonder if he's a fellow randomness guy. I mean, so obviously I'm all about selection. Selection is undeniable, but I think a lot of people, I've said this on the podcast before, they like to come up with adaptive stories when they see a trait, where there's, to be honest, it might have just evolved that way.
But I was just listening to a book about evolution and human behavior, and I remembered when you had said that before about these adaptive stories, because my background as a naturalist, like telling people, on nature hikes, that's what it's all about, all these stories. Right. But he did delve into that debate, Robert Sapolsky, his book Behave, fantastic. But he talked about how these stories aren't garbage because these stories can have, if they're based in observation and research, they can have predictive power, right?
I get that. But if we're going to talk about selection, you can provide evidence for selection. And it's not just with predictive power, it's with, you can actually show it in like the genome, for example.
Sure.
Like there should be multiple predictions on many different levels in biology, because you can prove selection. There's non-random mutations in genes that
you
catch
definitely
on.
know more about this than I do.
Sure.
Yeah.
But, so I mean, there's good ways of doing this, but
All right, so let's do our shout-outs. You ready?
Yeah, so first and foremost, we'd like to thank our growing list of Patreon supporters. So thank you to our new patrons, Kimberly R. and Colin G. updated his from $5 to $15.
Yes,
wow,
thank you, Colin.
Thank you. We also like to give a special shout-out each month to our top patrons. So stick around for the end of the episode to hear Bill's daughter Violet share that list. And if you'd like to support the podcast, consider becoming a patron of our show at patreon.com. Or you can make a one-time donation through PayPal on our website.
And you can always help out by sharing the podcast with friends and family and by subscribing and leaving us a review wherever you get your podcasts. It helps spread the word and allows us to reach a wider audience. We want to thank our newest iTunes reviewer.
No way.
The 69 guy 420.
That's my alt account, guys.
He just covered all the bases there.
I wish that was me, actually.
But he actually wrote an excellent, thoughtful, quite lengthy review.
Right.
Just talking about what we do, and it was very complimentary. So thanks to 69 guy 420.
So come enjoy our sporadic posts on Facebook, Instagram, and Blue Sky. And you can always email us ideas for episode topics, criticisms, or stories of your own personal encounters with great tits to thefieldguides@gmail.com.
And folks, remember to get those kids outside. Let them get muddy, let them get dirty, let them flip over rocks and logs. And if you don't have kids, make some time to get yourself outside. See you next time.
See you next time.
And here's Violet with this episode's top patrons.
Eric, Alyssa, Adam, Mary, Colin G, Dr. Judy, Kimberly B, Peter R, Callie, Rich K, The Hebranks, Orange Julianne, Rachel L, The Drunk Phytologist, Daniel M, Diane, We Named the Dog Indy, Hot Dog Cold Weather, Dwayne H, Jennifer D, Jonathan A, Michaela, Vale, Andy W, Elizabeth P, Picasso 3, John R, Evan, Mark T, Cecilia, Julie B, Dennis, Chris N, Sung, Jeff S, Jonathan K, Matt E, Plants in My Pants, Ryan R, Sophie S, Connor H, Measure and Principle, Fragaria pepiloinoidea, Outside Chronicles, Andrew C, Quixote, Max D, Melissa Marie in Dusty, Arizona, Kelly S, Sarah S, Helen A, Judy F, Ben C, Jane H, Doodle Dude 82, Galen Mac, Kazzies, Jeff S, Esther C, John W, Mark V, Bethany H, Rob M.
Take a breath. I always wondered if you're pronouncing Fragaria pepiloinoidea correctly.
I know, me too.
So that patron, if you're out there and you're listening and you stick to the end of the episode for this, let us know if we're pronouncing that correctly. Patrons, on behalf of Steve and myself, thank you so much for all of your support. As we always say, it means the world to us, and we will continue to try to live up to your support. Bye.
Goodbye.
To thefieldguides@gmail.com.
Do you want to keep that in there? Or
Yeah.
no? Do you?
Yeah, just do.
Because I put that in there and I'm like, I don't know if
Go
we
for
want
it.
to go. Okay.
I think everyone knows that. You made me read that. But I don't care. Even if someone thought that I was just saying, I'm also okay with that.
And folks...